All right, today we're digging into something really fascinating. It's an internal document dated just this morning, April 15th, 2026, and it makes a pretty radical claim. It basically suggests that when it comes to AI, we might have been trying to solve the wrong problem this whole time. So yeah, let's dive in. You know all the problems with AI right now, right? The hallucinations, the way it kind of loses the plot in a long conversation. We usually think of these as just bugs, glitches that will eventually iron out with more data or bigger models. But this document kicks off with a totally different question.
What if those aren't just little bugs? What if they're actually symptoms that the entire foundation we've built AI on is, well, fundamentally broken? And that's the wild premise we're exploring today. The blueprint for a completely new way to build AI you can actually trust.
Okay, so let's start with the big one, AI's trust problem. I mean, why is it that we can't really, truly rely on these systems for anything critical over the long term? The document argues it's not about making them bigger. It's that the very architecture is the problem.
This is the question everyone's asking. Why do these incredibly smart, powerful systems just make stuff up? They invent facts, they misremember things you just told them, they spit out nonsense that sounds perfectly plausible. And the scary part is, this isn't some rare glitch, it's what they do.
So here's how the document breaks it down. Hallucinations happen because the AI literally can't tell the difference between something it found and something it invented. And its core goal? It's just a pattern of what the authors call weightless bits, just an electrical state in memory. It can drift or get overwritten silently without a trace. And if the goal itself can just vanish, how can we possibly delegate a serious task to it? You just can't.
To fix all this, the authors say we have to go back to basics, like way back. Not to more complicated software, but to a simple, undeniable truth from the physical world.
And this is it. This is the bedrock of their whole argument. The classical exclusion axiom. Sounds fancy, but it's super simple. It just means you can't have two physical things in the exact same place at the exact same time. It's not a theory, it's just a fundamental rule of how space works. And this analogy just makes it all click. Think about a mailbox, right? If there's a package inside and you want to put a new one in, what do? You have to physically take the old one out first. It's a real, observable action. You can't just silently replace it. And believe it or not, that simple idea is the key to everything that follows.
So starting from that one single physical fact, the document builds what it calls an unbroken chain of logic. There are actually 22 steps in the paper, but we're going to focus on the 4 huge leaps that take us from that simple mailbox to a totally new kind of artificial intelligence.
Okay, here are the leaps. 1. Because physical position is exclusive, a specific address in a computer's hardware now has real, undeniable meaning. 2. You can take the AI's core goal, its intention, and physically anchor it to one of those specific locations. It's like putting the package in the mailbox. 3. Because it's physically anchored, it can't be silently changed. To alter the goal, you have to perform an observable action, just like taking the old package out. And 4, the big payoff. If the intention can't drift away, you can finally delegate tasks to an AI with verifiable proof that it's still working on what you originally told it to do.
And all that leads to this core concept, substrate-anchored intention. Yeah, it's a bit of a mouthful, but the idea is powerful. The AI's goal is no longer just a fragile pattern, one of those weightless bits, but an actual, durable physical fact that's part of the system's hardware.
Now this is where the argument gets really provocative. Because the claim is that by building an AI on this foundation, you don't just make it safer, you actually unlock a completely new level of performance. They call it the delegation equivalence. The big idea here is that safety and the ability to delegate aren't a trade-off. They're not two different things. They're just different ways of looking at the same property. An AI you can trust to stay on task is, by its very definition, a more capable AI.
Let's just put it side by side. In conventional AI, the intention is just a flimsy pattern of bits that can drift off. In this substrate-grounded AI, the intention is a physical thing locked to an address. Conventional AI constantly confuses finding information with making it up. This new architecture separates them at the hardware level. The bottom line? You go from a system that has a ceiling on its reliability to one where you can actually verify that it's doing its job.
And the analogy they use here is just perfect. Volvo. Volvo built its entire brand on being safe. They never saw safety as something that held back performance. Safety was their performance. It was the core capability they sold. And the claim here is exactly the same. Building a verifiably safe AI is how you build a more capable one.
And what's the most direct benefit of all this? A hallucination floor. That's their term for it. Because the system's architecture physically separates retrieving information from generating it, that core confusion that causes hallucinations in the first place is basically eliminated, not by training, but by design.
So, okay, we have this incredibly powerful theory. But what about the real world? The end of the document gets very real, laying out both the huge strategic power of this idea and its one single critical vulnerability.
I mean, talk about confidence. They lay out what they call the competitor's trilemma. They claim that if their logic is sound, then anybody else trying to build a truly reliable AI has only 3 choices: license this architecture, accidentally build something similar and get sued for patent infringement, or simply fail.
But then comes the catch, and it is a huge catch, which they admit themselves in their own analysis. They call it the vapor tripwire, and it puts this entire grand vision on a razor's edge.
And here it is, the big secret. The idea is fully baked, the logic is sound, the patents are in motion, but the software doesn't exist. Not a single line of code. It's pure vaporware at this point. And they know that if a competitor finds this out, it could be absolutely fatal to the entire project.
So that's where we land. On one side, you have this elegant, potentially revolutionary idea, this unbroken logical chain from a simple physical fact to a whole new generation of AI. But it's in a desperate race against a brutal reality. You can't change the world with an idea you haven't actually built yet. The only question is, which one wins the race?